Hey there, okay, so here's the solutions video for the Module 5 practice test. Alright, first problem, draw an exterior angle of that triangle. There's one. I could draw another one. You could draw any of them. I just take any side and extend it out a little bit. Oh, that's not very good. And then draw the angle between that extension and the adjacent side. There you go. There's a couple of exterior angles. Alright, here's a pair of vertical angles. Just cross two lines. You get vertical angles from two crossing lines, and the angles opposite of the intersection point are called vertical angles. There you go, and they are congruent. Here's a picture of a kite, and the way that you know that it's a kite is by the fact that these two sides, these two consecutive or adjacent sides are congruent, and then these two adjacent sides are also congruent. That's what a kite is. It's got quadrilateral with two pairs of adjacent congruent sides. Alrighty, then the special thing that happens when you have a rhombus that's got four congruent angles, that's called a square. Congruent sides makes it a rhombus. Congruent angles makes it actually a rectangle, and any shape that is both a rectangle and a rhombus is called a square. Alrighty, next one is the proof of the exterior angle theorem. Alright, the exterior angle theorem says that an exterior angle in a triangle is equal to the sum of the two remote interior angles. So using these numbers here, that would mean that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So here's how my proof goes, and proofs can be a lot of forms, but I'm just saying this. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees, and that's because the sum of all the angles in a triangle is always 180 degrees. Also, measure of angle 3 plus measure of angle 4 equals 180 degrees because they are a linear pair. That is, they are supplementary and they form a straight angle. So using algebra, we can say this, and a little bit of substitution. We can say that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals the measure of angle 3 plus measure of angle 4, because they both equal 180. So if they both equal the same thing, then they equal each other. Alright, then if I subtract, so then by subtracting measure of angle 3 from both sides, I get measure of angle 1 plus measure of angle 2 equals measure of angle 4. Well, heck, that is what I was trying to prove. So that worked, viola, or voila, or QED, and we're done with that. Now let's flip over to the next page. Alrighty, and we have a couple of things here. There's a couple of parallel lines crossed by a CD. That is called a transversal. That's what the line CD is. And if that measure is 154 degrees, that would be 180 minus that, which happens to equal 26. So all of these angles in here are either 154 or 26 degrees. So this is how the chart breaks down. And so I don't have to read all of these off. 26, 154. Everything that's obtuse is 154, and everything that's acute is 26. All right, we're going to move on to the next proof, which is to prove that angle 1 is congruent to angle 3. That is a vertical angle theorem, but I can't just say, oh, they're vertical angles. No, because that's what I'm trying to prove, actually. So here's how I did that, very similar to the other proof. Angle 1, measure of angle 1 plus the measure of angle 4 equals 180 degrees. They form a linear pair. And measure of angle 4 plus measure of angle 3 equals 180 for the same reason. Measure of angle 4 and 3 there. So if measure of angle 1 and 4 is 180 and measure of angle 4 and 3 is 180, that means they both equal the same thing, and therefore they are equal to each other. So measure of angle 1 plus measure of angle 4 equals measure of angle 4 plus measure of angle 3. Now if I subtract the measure of angle 4 from both sides of that equation, I get simply measure of angle 1 is equal to measure of angle 3. Therefore, angle 1 is congruent to angle 3 and QED. We're done. That's what we proved, that the vertical angles are congruent. Let's look at these other problems, triangle congruence patterns here. These two triangles are congruent by side, angle, side, side, angle, side, side, angle, side. So here is one possible congruency statement. CAB is congruent to GEF. All right, just as long as you spell the triangles in the matching order, then you're good. The next one is yes, that those two triangles are congruent by side, side, side. Here is one possible congruency statement. ABC congruent to CDA. All right. Part C, these two triangles show all congruent angles, but that doesn't mean they are the same size. They are the same shape, but not the same size necessarily, so we'd have to say no, they are not congruent. Angle, angle, angle doesn't work. Part D, we do have congruent triangles, so we forgot to circle the yes there. There we go. By angle, angle, side, or if you want to, you could make a very good argument that that is angle, side, angle, because if these two angles are congruent and those two angles are congruent, since all the angles in a triangle add up to the same number, 180 degrees, these two angles up here must also be congruent. So we do have congruent angles there, and so we could say angle, side, angle, all right? Angle, side, angle. But angle, angle, side also works. So there's a congruency statement for you to think about. As long as you are spelling both triangles in the same order, showing corresponding points, then you're good. Let's look at the next page, which is a couple of problems here. These are congruent angles, so I need to just write an equation showing that they are congruent angles. Pretty easy. And I write that equation out, solve it for y, and I get 27 equals y, and we're done. That's what we had to do. Here's a triangle with an exterior angle, which, as you recall, is the sum of the two remote interior angles. So 20x equals 60 plus 7x plus 5. And that, when I simplify that down, solve it for x, I get x equals 5. Here we have a couple of vertical angles. So x plus 16 equals 4x minus 5. I work that angle, that equation out, and I get x equals 7. Okay? And over here, looks like I forgot to finish this one, but I'm setting all of these angles together to equal 360. And so that's 369x plus, let's see, 90 plus 30 is 120 plus 15 is 135. So 9x plus 135 equals 360. And 245 divided by 9, I'm sorry, yeah, that's what that is. 245 divided by 9 equals 27, 27.2, repeating. Okay, so that one didn't give me a nice whole number answer, but that's okay. There's our answer for that one. And here's a proof of these alternate interior angles being the same. I drew a picture, I numbered the angles here, and I got angle 3 and angle 6. I'm going to prove that angle 3 is congruent to angle 6. All right, so here's how I'm doing this. I'm saying that angle 3 is congruent to angle 7, or their measures are equal, because those are corresponding angles. Okay, so I have that. Measure of angle 3 equals measure of angle 7 because corresponding angles are congruent. Being a little symbolic here, hope that's okay. And measure of angle 7 and measure of angle 6 are equal because they are vertical angles. All right, so 3 and 7 are congruent because they're corresponding. 7 and 6 are congruent because they are vertical angles. All right, so then I got measure of angle 3. Hi there, how's it going? Measure of angle 3 equals measure of angle 6, and by the transitive property then, I'm sorry, I skipped the statement here. So if measure of angle 3 equals measure of angle 7 and measure of angle 7 equals measure of angle 6, then measure of angle 3 equals measure of angle 6 by that thing called the transitive property. Therefore, angle 3 is congruent to angle 6. We're done. That's a good one. All right, is that it? That's it. That's the whole thing. All right, hope you enjoyed that. Now, hope you're ready for the test. Bye-bye.